Hello everyone, this is Sri Guru. Welcome back to my YouTube channel. And I want to say this, don't forget to like, share and subscribe. When you subscribe to my channel, then you will get the immediate notification whenever I uploaded the videos. So that you can see that on that instant. Okay? Right. In the previous video, we discussed about the physical quantities. Like physical quantity means the quantities which we can measure. If there is a cylinder, we can measure the length of the cylinder. We can measure the outer diameter of the cylinder. The diameter, length, all these are the physical quantities. Right? The quantities which we can measure. By using certain instrument, we can measure the length of the cylinder, outer diameter of the cylinder. Okay? And here I am going to discuss about the accuracy and precision. Accuracy means think that there is a very true value like value is around 7.567 centimeter. This is the true value of this cylinder. But when I measure this length of the cylinder by using the normal scale, this is a normal scale, right? Then I got the value of measured value 7.5 centimeter. 7.5 centimeter. Once again, I measure this instrument by using the another instrument. I will measure this length of the cylinder by using the another instrument, like this is a vernier calipers. This also measures the length of the object. When I measure this length of the cylinder, then I got second. This is the first measured value, and this is the second measured value. Measured value 7.36 centimeter. Which is the more accurate? Whether this value is more accurate, whether this value is more accurate. This 7.5 is very close to 7.567. Therefore, this value is called accurate value. Look at the definition here. Accuracy means the closeness of the measured value to the true value of the physical quantity. This is very close to this. Therefore, this value is called accurate value. Precision means here after the decimal point I got only one number 5, but here after the decimal point there are 2 digits are there. But this is more precise than this value. But however it is more precise, the true value or the accurate value is 7.5 only. This is the accuracy and precision. Now look at the error. Error means there is whenever we measure certain physical quantity, we will get the error. Error means it is a simple definition. The difference between true value and the measured value. Difference between the true value and the measured value. This is the measured value and this is the true value. Whenever we take the difference between these two, then here I have written error is equal to true value minus measured value. True value is 7.567 minus measured value is 7.5. Then how much will get the difference? It is 0.067. This is the difference, right? This is what we call error. This is the difference between true value and the measured value. Correct? This is the error. Error means there is a certain mistakes. These mistakes or this error are different types of. The first one here, systematic error, which occur according to a definite patterns. Whenever we get this type of errors, this follow a certain pattern, right? That type of error is called systematic error. Among the systematic error, there are once again there are different types of systematic errors are there. Now, the types of systematic errors are, the first one is instrumental error. When we are manufacturing the instruments, there may be defects in the instruments. Because of that reason also, we will get the errors. Like if this is a scale, the numbers are printed on this scale. If any one number is misplaced or something, it is not printed on the scale, then whenever we measure the length by using this scale, we will get the error. Such type of error due to occurring due to this instrument is called instrumental error. And the next one is personal error. Personal error means because of the carelessness of the observer, we will get the error. If somebody says to you, measure the length of this duster, by observing someone else and you are measuring here and you will get the difference, that due to the personal lack of the concentration, we will get the error. Such type of error is called personal error. The third one is natural error. Because of change in the temperature, because of change in the pressure, because of certain surrounding system, they are continuously go on changing. That reason also we will get the error. Such type of error is called natural error. This is the types of errors which are belonging to the systematic error. This is the first type. The second type is random error. We cannot predict the error. Because of this reason only we will get this error. ನಮಗೆ ಹಿಂಗ ಅಂತ ಹೇಳಲಿಕ್ಕೆ ಬರೋದಿಲ್ಲ. ಈ ಎರರು ಇದೇ ಕಾರಣಗಳಿಂದ ಬರ್ತದೆ ಅಂತಂದು ಅಂತ ಎರರಿಗೆ ನಾವು ಏನಂತೀವಿ ರ್ಯಾಂಡಮ್ ಎರರ್ ಅಂತ ಹೇಳ್ತೀವಿ. Then how we can make it correct? Right? By taking the arithmetic mean of these errors. Like these are the measured values A1, A2, A3, so on an. This A1, A2, A3, An, all these are the measured values of n times. When we take arithmetic means, that means A1 plus A2 plus A3 plus so on plus An whole divided by, how many times we have measured this value? N times. Then n. Then we will get arithmetic mean. This is how we can reduce the error, by measuring the number of times, and when we take the mean of that values, arithmetic mean, then we will get the we can reduce the error. Okay? Okay, listen. Then how we can express the errors? How we can express the errors? First, let's take x1, x2, x3, so on. Yes, n times I have measured certain physical quantity. Then to reduce the error, what we have to do? First, we have to take the mean value of this. Or just write x mean. This is also we can write x bar. Okay. Then to get the x mean, we have to take the x1 plus x2 plus so on plus xn whole divided by, how many times we have measured the physical quantity? N times. Then we will get true or the mean value. Correct? Next, there is a, to express the error, we have to take the absolute error. Absolute error. Absolute error. Absolute error means it is represented by delta x. Whenever we take the difference between this x mean minus the ith time measured value, that is first we have to take x1, right, then we will get this absolute error. Whenever we take this x mean, we have to take the magnitude value. The absolute error may be positive or negative, but the magnitude of absolute error is always positive. Okay. Similarly, we have to take the second mean absolute error x2, that is x mean minus x2. Similarly, for the third value, magnitude of delta x3 equal to x mean minus x3. Like that, we have to take n times delta xn is equal to x mean minus xn. Right? This is what we call absolute error. The definition is, it is the only difference between the mean minus ith measured value, that is absolute error. Next procedure is mean absolute error. Mean absolute error, what we have did in the earlier, we have to follow the same procedure to get the mean absolute error. That means we have got different absolute errors. We have to take the mean value of this. Okay. Therefore, and it is represented by delta x. Delta x. This is equal to delta x1 plus delta x2 plus so on delta xn whole divided by how many times we have it? This is n times. This is mean absolute error. Correct? The next one is, after the observing mean absolute error, we got this delta x. This is relative error. Relative. That means we have to compare this with a standard value. Then the ratio of mean absolute error to the true value of the mean. This gives the relative error. The ratio of, look at here, you represent this as a delta x mean, and relative error I will represent this as a del x equal to magnitude of delta x mean whole divided by x mean. This means what? This value. Whenever you are calculating the mean absolute error, we have to consider the magnitude of these values. Either it may be a positive or negative, but when we are calculating the mean, we have to take positive only. Similarly, this value got also positive only. Therefore, the delta x mean this value divided by this mean value. Then we will get the relative error. The last one is percentage of error. Percentage of errors, this is equal to relative error into 100%. Into 100%. Then we will get percentage of error. That is, relative error is how much? Delta x into 100%. Then we will get percentage of error. Okay, this is the procedure to express the errors. We will solve some problems to calculate the percentage of error. Then you will come to know. See here, I have written a problem to calculate the percentage of error. The time period of oscillation of simple pendulum in an experiment is recorded as 2.56 seconds, second 2.62 second, third 2.70 second, next 2.58 second, next 2.45 second respectively. Find the time period percentage error. He asked you to calculate the percentage of error. Right? What he says, there is a pendulum which is oscillating between the two extreme positions. Right? The time required to complete one oscillation, it takes different measured values. Correct? Then what is the percentage of error in this measurement? He is asking. For that, we have to follow the procedure what we have did in the previous. First, we have to calculate time period. Therefore, I will mention T rather than X. T mean, or this is T bar. Okay. Now write down the values, measured values. 2.56 plus 2.62 plus 2.70 plus 2.58 plus 2.45 whole divided by how many times he has calculated the time period? 1, 2, 3, 4, 5. Therefore, number of times 5. Okay. After the simplification of this T mean, how much we will get? Calculate this. It is 2.58 seconds. This is the mean value. Right. Next, what we have to do? First, we have to calculate mean. Next, mean. So, absolute error first. Absolute error. Absolute error na hang ಮಾಡೋದು? First, what is the true value? This is the true value. Correct? Delta T1 is equal to, this is true value, T mean minus what? This is T1. This value is, first value is T1. 2.58 minus 2.56. Then the difference of this value is 0.02 seconds. Even though if I get this value in a negative, then we have to take the magnitude of the value. That means it is always positive. For the second, delta T2, rather than writing this value, I will directly write true value 2.58 minus second value 2.62. Correct? Then the difference is how much? What is the difference? 0.04. 4. Here I will get the negative value, but even though I have written here positive. Next, delta T3 2.58 minus third value 2.58. Then the difference is 0.00. Correct? Next, delta T4 2.58 minus fourth value 2.45. What is the difference? How much? 2.58 minus, it is 0.13. Next, delta T4 2.58 minus, we have missed the one value, that is 2.70 here. Okay, right here, 2.70. It does not make any much difference, just right here, this is T5. 2.70. Then we'll get 0.12 seconds. This is the absolute error. This is how we can calculate. But look at properly, I have not written here any negative sign, even though I get in this case and in this case, but I have written here positive values only. Okay. Next, mean absolute error. Mean absolute error. So that we have to take the mean value of this, that is delta T mean. Formula is magnitude of delta T1 plus magnitude of delta T2 plus magnitude of delta T3 plus magnitude of delta T4, similarly plus magnitude of delta T5 whole divided by number of times 1, 2, 3, 4, 5. Therefore, delta T mean is equal to, the first value is how much? It is 0.02 plus the second value is 0.04 plus 0.00 plus 0.13 plus 0.12 whole divided by 5. Okay, simplify this. How much you will get using the calculator? Measure the mean absolute error. Mean absolute error. ಎಷ್ಟು ಬರಬೇಕು? 0.062. ಎಷ್ಟು ಬರುತ್ತೆ? 0.062. 62 seconds. This is mean absolute error. Next, percentage of error. Last. What I say? This is the ratio of delta T mean magnitude whole divided by T. This gives the percentage of error. Correct? What this value is? 0.062 whole divided by T means how much? It is 2.58. After the simplification, for this we have to multiply 100%. Simplify this. 2.4%. 4%. This is the required answer. If you want to express errors, T is equals to T plus delta T in the form of errors plus or minus. This T value is nothing but T mean, this value 2.58. This is T. And this delta T means this value T mean, and it is plus or minus 0.06. This is how we can express the errors, but percentage of error is 2.4%. This is the error. Now I will give the homework. See, this is the next example I have written. This is homework for you. The refractive index of a glass in an experiment is recorded as 1.52, 1.48, 1.50, 1.54 and 1.45 respectively. Find percentage of error. ಹಾಗಾದ್ರೆ ಈ ಪ್ರಾಬ್ಲಮ್ ಅನ್ನ ಸಾಲ್ವ್ ಮಾಡಬೇಕಾಗಿರೋ ಜವಾಬ್ದಾರಿ ನಿಮ್ಮದು. ಹಾಗೆ how to solve this? Follow the procedure what we have did in this previous example. Okay, first we have to calculate mean of these values. Next, absolute error. Absolute error means the mean value minus the ith value. Next, delta mean absolute error, that is what we have got in this here, that is delta A mean, delta A1, delta A2, so on. And next, in the last one is percentage of error. This is mean absolute error divided by mean into percentage, then we will get percentage of error. After the calculation of percentage of error, you have to express this value for this experiment. Okay, thank you for watching my video. We will discuss some more problems in the next video. Okay, thank you. Don't forget to like, share and subscribe.